Hello everyone and welcome back to my online teaching platform. We are still looking at application of differentiation in relation to how to determine small changes. Alright, so here we have our fourth problem and we have to find a solution to this problem. Okay, so let's start with a variable quantity. A variable quantity L is directly proportional to the square of another variable T. If L increases by P%, that is P being small, estimate the corresponding percentage increase in T. All right. So let us get an equation for the first part of the given statement. A variable quantity L is directly proportional to the square of another variable T. So this is a direct variation. Okay. So we start by, so we have the first variable quantity to be L, which is directly proportional to the square of what? T. So T squared. Then you now introduce your constant of variation, which is L is equal to K multiplying T squared, where K is the constant of what? Variation, of variation. Write it here. K is the constant of variation. Okay, all right. So this is our equation now, and we are to determine a corresponding percentage increase in T as a result of a small increment in what? The L. Okay, because the L depends on the T. So if there's if there's an increment in L, it implies that there was an increment in what? T, and that resulted in an increment in L. All right, so we were given the small increment in L, and we have to find the small increment that has occurred in the T. And after that, we'll find the percentage increment or the percentage increase. So for you to find a percentage increase in the T, you have to first find the increment in T first. That is a small change in T, before you can use that value to determine the percentage change or the percentage increase. We are specific why, because it has been increased, so they are saying that percentage increase. All right. So you know that we have a function L in terms of T. So L is equal to KT squared. So our the L dt is approximately the same as the small change in L divided by, with respect to the small change in what? T. All right. So let us take the left hand side of the equation first. So we are going to find our dl dt. And we are going to differentiate the function L with respect to t. And we are going to get the result to be 2kt. Alright, so this is our dl dt. Now let us also find our small change in L, because we have been given the we have been given the increment. I think we have been given the increment. Okay, that is P%. The if L increases by P%, so it means that is the increment. So the increment in L will be P% of L. Okay, P% of L, and this will give us PL of 100. That is P times L divided by what? 100, because of the percent. Okay, and this is the same as 0.0 P L. Okay, 0.0 PL. There will be 1 over here. Let me write it well. So we have 0.01 PL. Okay, when you divide PL by 100, you are going to get 0.01 PL. Or you can still use the PL divided by 100 to get your answer. You are going to get the same answer. All right. So we have our DL dt equal to small change in L divided by the small change in what? T. We are focusing on the small change in T. So we know the L dt to be 2T, sorry, there's K here, 2KT, all right, equal to, that is PL divided by 100 divided by the small change in what? T, right? This is the small change in the L, all right? So we need to make small change in T the subject. So let us cross multiply first. We are going to get 2KT multiplying the small change in T equal to PL also divided by 100. All right. I'm just repeating this side, the one in the bracket. So here will give us 2KT multiplying the small change in T equal to PL divided by 100. So we are dividing through by the coefficient of small change in T, which is 2KT. Here to be by 2KT, right? And this will give us, we are going to get the result of small change in T being equal to PL divided by 100. Then you divide it by, then we have the 2KT. All right. So we can now rewrite it as small change in T being equal to PL divided by 100 times the reciprocal of 2KT, which is 1 divided by 2KT. And we are going to get our small change in T to be equal to PL divided by 200 KT. All right. Now you could say the L here, but we know our L to be, but L is equal to KT squared. Okay, L is equal to KT squared. So we are going to replace this L with KT squared. All right. We need to express everything in terms of KT. So we are going to get our small change in T to be equal to P multiplying KT squared divided by 200 KT. All right. So here we are going to get it to be K divide itself. K also divide this. T divide itself here. We are going to get 1. T here we are left with T. So the numerator becomes PT divided by 200. All right. PT divided by 200. Okay, so this is a small change in T, and we have to find percentage increase. Okay, this is a small increment in the T, but we have to find a percentage increment. Okay, or the percentage increase. So that would be percentage increase in T. Okay, will be equal to small change in T divided by the original T times 100%. Okay, this is how we find percentage change. Is a change over the original times 100%, right? So the percentage change, okay, you know our change to be, the small change to be PT divided by 200, or will be divided by T. That is the value of T, the original T, times 100 what percent. And this will give us PT divided by 200 divided by the T, right? So I'm just expressing it in this form. multiplying 100%. And here we are going to get it as pt divided by 200 times the reciprocal of t, which is 1 divided by t, multiply 100 what percent. So this t divide itself 1, here 2, 1. Then we are left with p divided by 200, okay, times 100%. Okay, so here 100 divides itself 1, 100 divides 200, we are going to get 2. All right, so we are going to get it to be p divided by 2%, which is the same as 0.5 p percent. So this is the corresponding percentage increase in t when the L is increased by, or when the L was increased by p%. All right, so this is the corresponding percentage increase in the t that we are supposed to find. Please, thank you for watching. Please do not forget to subscribe to my YouTube channel, which is Math with Ebefa, and you can equally share my videos with others to also watch and comment on my videos. Thank you for watching. Bye.